breeze, so I've got my little propane heater right here because it is cold. Okay, let me show you what we're going to do today. Here is the camera flip. Come on, there we go. There's a sack from Rolly's Red Barn full of clay. It's partially dried. This is a sample I've been playing with the other day. And wow, shadows suck. You can see we've already got a couple of concretations or blueberries, little spherules right on top, just like what we've had before. So Jack Graham is my father-in-law, and he gave me the idea to test these with a magnet. So here I've got a small little magnet. I've got two spherules that are dried. Ah, yes.
Steve Whetstone. I wish we could see a graph of the electron's density and frequency and velocity when the electrons hit the rock surface. I assume there's no free protons in your plasma electric arc. I wonder what % of electrons get absorbed permanently into the clay or spherules. The reason your spherules don't conduct after solidifying is known. I expect the concretion works the same way with a double-layer charge separation between the air and the solid or liquid clay surface. You might like this video on double layers in clay and electron drift transport and densities in clay and silicates. This video lecture about electrons in clay explain a lot of what seems to be happening. It's kind of boring, like sitting in a classroom, and I think it's actually part of a class on the subject online for free. It will explain the electron density in the clay and why the spherule conducts electricity or not. It's #electric universe earth science, I guess. Might be relevant to #telluric current too. Sincerely, Pash Strawwood Whetstone Forking Prit Solutions for Earth Catastrophe Cycle S4AC 2048. Steve Whetstone. P.S. I love upvote your post for being the first person to perform the magnetic experiment part of the spherule and electrification for the public. A fake. I want to add your video to my YouTube collection of pirate treasures. I've been wondering about magnetism. Here's a related video on magnetism that talks about the magnetic and electric moments of silicates and clay. If you've ever wondered what frequency of electric plasma will most melt which elements or molecules, then this is the video for you. Maybe it's another boring classroom video type thing and may be of interest to you, but maybe not. Let me know with a vote what you think if you get around to watching it. How do you think your video should be, before or after this video in my playlist archive of solutions for Earth Catastrophe Cycle 2048? I believe your research may have applications and find it personally very interesting.
When it rotates around its own axis, this is the direction of spin, let us say, it also generates another magnetic moment. And this two different movement, that is the two different magnetic moment, has some specific name, and this spinning around its own axis means I am talking about this case, which could be either up or down, means opposite side, okay, in this side or in this opposite side. This is up and down, and this magnetic moment, that is called as plus or minus mu b, is known as Bohr magnetron. Now, this is case A, and in case B, or let us say 2, where we also generate a magnetic moment, that is due to the orbital motion. So, in a orbit, the electron move around the nucleus, and being a moving charge, or let us say a electron,
crisis. to commence. We're going to talk about that in a little bit more, but first we're going to take a deep breath and we are going to see you on the other side.
The dream is on.